Warm welcome to everyone joining. Thank you for being here. Go ahead and get yourself ready. Grab a notebook, a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a nice little problem. It's in the topic of algebra, more generally in number theory. And it's an SAT style problem. But I didn't provide any multiple choice answers here. It would be too easy to give you that, because then you would simply be able to check. Okay, so go ahead and give the problem a read. Pretty simple. Make sure you can interpret the problem. It's part of the challenge of this one. Give yourself about 2 minutes. Maybe you can finish it faster. And then when you're ready, go ahead and unpause the video. Check back, see how we did it here. Okay, so let's get started. We want to find two consecutive. What does that mean? That means one after the other. Even integers. Okay, so that's really important. That means that if we have 4, that the next one wouldn't just be the next number, it would be the next even number, like 6. That's how we determine consecutive even integers. They're basically even numbers that are 2 spaces away, and so they're considered consecutive even numbers because they're 2 spaces away. We want their sum to be the sum of their reciprocals to be 9 over 40. So of course we need to be able to represent this somehow. Right, so let's start with one of the numbers we can just call x. And then the other number we can call x plus 2, because that would be the next even number. We need the sum of their reciprocals to be 9 over 40, which means we need 1 over x plus 1 over this other number, x plus 2. We need this to be equals to 9 over 40. Now, of course, when we have fractions here, 2 fractions with different denominators, and we're trying to add them, it's not going to work. We need the same denominator. So let's get the same denominator here. We're going to multiply this one by x plus 2 over x plus 2. And then we're going to multiply this one by just simply x over x. Really easy. Now, I don't need to multiply those things to both sides. I just need to multiply the top and bottom of each fraction by the same thing. So this fraction multiplied by x plus 2 over x plus 2, that's pretty much like multiplying by 1. And then this one we're multiplying by x over x, that's also like multiplying by 1. So altogether, we get x plus 2 plus x. And now the common denominator that we've created is x times x plus 2. And this is equals to 9 over 40, right? So we can combine like terms on the top. We have 2x plus 2 over x times x plus 2. And that's going to be equals to 9 over 40. Now, what I would recommend is just doing some cross multiplication here. I would just cross multiply these things, and you'll end up with a quadratic. So you'll have 40 times 2x plus 2, I know it's a pretty big number, equals 9 times x plus 2. Okay, very simple. And this is going to turn into a quadratic, because if I distribute on the right side, you'll see that we have an x squared term. And on the other side, if I distribute, I have 80x plus 80. So let's get everything over to one side. Hopefully some magic will happen here. No guarantees, no promises. We have 9x squared. Subtracting 80x from both sides, that's going to leave us with negative 62x. And then we're going to subtract 80 from both sides as well. So apparently we're going to get some integers out of this. Looks a bit messy. If if you're considering this, factoring is a good way to consider it. I know the numbers are large, but just bear with me here. 9 times negative 80 is negative 720. So we need two numbers which multiplies as negative 720. And they have to add up to negative 62. And hopefully you can think of like the most obvious way to do this, other than multiplying by 1, is to multiply by 10. So this is precisely negative 72 and positive 10. So let's see what that breaks down to. A lot of people will do this next step in many different ways. That's okay. I prefer to go with the grouping method. It's what I grew up with. There are other methods that are quite quick as well. But with grouping, we factor out 9x, leaving x minus 8 from the first group, and then we factor out 10, leaving x minus 8 from the second group. And upon seeing these factors, you can tell that we're only going to get a whole number, an entire integer, from one of them. Right? This would lead us to say that x equals negative 10 over 9, which means that it does technically solve the equation. And if I add 2, that would be 8 over 9. And those two numbers technically do solve this situation, but the question asks for even consecutive integers. So here we're going to have that x equals 8. Therefore, the other integer is 10. So if we had some multiple choice options, you'd be picking 8, 10. Right. So this problem came down to solving a quadratic. And we're really just flipping whole numbers, which is a very simple concept, but finding what those numbers are was quite challenging if you're not comfortable with quadratics. Now, if you didn't realize that factorization, you're welcome to use the quadratic formula, but I can't guarantee that that's going to end up very good for you. You'll end up multiplying much bigger numbers than you have to deal with if you're just factoring. For example, I'll just set it up. We'll have 62 plus or minus square root of negative 62 squared minus 4 times 9 times negative 80. Yeah, that gets a little bit computational heavy, so if you don't want to do that much computation, just get better with your factoring. Although this technically does reduce to some nice numbers, apparently. It's not obvious. You'd have to do quite a lot of work there, right? Okay, I think that's enough blab out of me, unless you guys would like to see me go through the pain of working all that out, but it's actually really easy for me, so I don't think it serves any good purpose here. Okay, yeah, that's enough blab out of me. I'll catch you guys next time.